Good afternoon. I hope you had a good tea or coffee. So today I'm going to talk about Galera instances. For those of you who are not aware of it, Galera is basically a transaction-aware communication library, and it is a vital part of CoderShip cluster or MariaDB Galera cluster or Percona XtraDB cluster, which is basically used for synchronous replication between MySQL instances. Anyways. Okay, so synchronous replication. So basically, I think some of you, or maybe all of you, are aware of async replication in MySQL, which is master-slave type. So there was a need for synchronous replication. This is one of the solutions. There are other solutions which I'll just mention in a while. So this is a synchronous replication. So as synchronous replication, as you do a commit, it returns only after it's completely replicated to all the nodes. But there's a caveat here is that there is a particular option which ensures that even the apply is synchronous. So to avoid latencies, there are certain optimizations which are used, which I'll discuss after some time. Anyways, so virtualization. So virtualization is why I'm mentioning virtualization with this. So the reason is high availability. I think nowadays with everything in cloud or almost everything going to cloud, well, yeah. So high availability is one of the major requirements for that, and virtualization has been used for it in hosting and such things. And the replication, one of the main aims of this clustering with PXE or Galera is high availability. So that is the commonality which I'm going to talk about now. So as I mentioned, what the Galera and PXE is. PXE is basically MySQL which uses Galera. And how do they work? I think I already did that. And it's a one of the main things I want to mention is it's MySQL compatibility. It's basically MySQL itself as you talk through the client. The workings are all behind the scenes. Okay, there's a synchronous replication. I just wanted to mention Google's F1 and Spanner. F1 is their RDBMS synchronous replication, which works on Spanner. I was reading the paper, and they mentioned in the paper that they were earlier using similar replication or sharding, and they couldn't. At that moment, they did not have any solutions, so they developed their own based on Spanner, which uses HDFS. If I am not wrong. No, sorry, it uses Google's big table. Sorry. And there's also MySQL NDB, which is network, which is currently an offering from Oracle, which was earlier with MySQL. So NDB is the network database, which also provides sharding in addition to synchronous replication. So that's why I mentioned sharding there. So sharding is not part of what I'm talking about now, but it's just another thing. I hope you know what the sharding is, where you split the data for performance reasons, among others. Okay, next I'll just briefly talk about virtualization, and then I'll come to how I'm going to talk about both. So I think popular solutions, you have OpenStack, which uses these KVM and other things. Then you have containers. Okay, I just wanted to mention that when I say virtualization, I don't mean strictly a KVM, but it can also mean containers in some circumstances. So we have LXC, we have Docker, which uses a modified LXC, if I'm not wrong. And then we have something like 0VM, which are application isolated virtual containers, which is relatively recent from what I've seen. I think that uses NACL, Google's NACL. So virtualization constraints. So what are the constraints when we are using virtualization? I think it should be obvious that it's one of them is the hardware and the performance and those things. What are the advantages? Advantages, again, it should be obvious. If you are using virtualization, you're not underusing your hardware, and so that is one of the things which is applicable here. And again, the high availability, which I mentioned just a while back. The cloud. Okay. So the data centers. I mentioned WSC. What is the WSC? It's basically a warehouse style computing. I'll just mention it. Okay, so what I mean by that is nowadays when companies like Google, Yahoo, or Microsoft, any one of them, they have their clusters. They're not like the hosted servers which we use. Like, I mean, the servers, they have a relationship between them. They have a common purpose, and the application is usually distributed among the servers. The other server clusters are like Hadoop or Manta from Joint, some of them, but those are the applications. But this is in general I'm talking about for warehouse style computing. And again, the demand of such a computing is that the whole section of a data center should behave as a single computer, as a single computational entity when it needs to meet the demands of performance or high availability and things like that. Okay, so for this kind of virtualization which is being used, we have seen like GlusterFS or which can be used with QEMU, or Sheepdog, which is used as a storage virtualization with QEMU again. I'm not sure if any of you have heard of it. Anyways, so next I'm talking about application level clustering and how it works. One more thing I just would like to point out is I mentioned Hadoop and Manta earlier. So those are, some of them have a SQL interface, but those are not purely SQL. Whereas the one presented here with Galera is a purely SQL interface. All the things, all the complexities are hidden behind the server. Sorry, and the Galera does the heavy lifting of communication between the nodes. Basically, it's not a vanilla MySQL which works. It actually has something called right side replication patch, which helps with this. It's not in the vanilla MySQL tree. Anyways, so when I mentioned scenarios, yeah, so the warehouse style computing is one of them, and saturation. So I've seen many deployments of Galera where a single application may not be able to saturate the entire node. So we can have multiple instances. So that is one of the deployment scenarios. And again, with high availability, you can migrate to other nodes. And one more thing is this kind of synchronous replication, it also works over the WANs. It's not just over the LANs. And it is WAN aware. So that is another thing. And one more thing is the isolation, which may not be required in a WSC scenario, but again, it may be required when you are hosting the databases of different clients. So you don't want them to interfere with each other. Anyway, so this is just this is where I talk about them in unison. I mentioned the both. So some of the things which can be used in such a scenario, I would like to mention. Note that some of these may not be specific to Galera alone. I mean, it can be used elsewhere, and it may not. And some of these terms may be KVM specific, but the other things, they have their own corresponding entities. Anyways, so what I mean by bootstrapping is, so you have a node. One node doesn't make a cluster, right? So you need another node. So how do you make it bootstrap? How do you make another node join this? So it needs the state of another node transferred to this node. So that is what I mean by cloning. The bootstrapping is where you bring up a single node. So that's fine. But the cloning part is where the state of that node needs to be transferred here. And that is something which is done through a method called snapshot state transfer. We call that snapshot state transfer, which transfers the runtime state of that node. And so this can be done through something called zero copy IO, so which is copy on write, and so that you don't have to copy the original image, and whereas it can share only the base image can be shared, so it reduces the IO considerably. Otherwise, if you have a database like, I don't know, 100 gigs, you'll have to copy the entire thing for no other reason. And then you can also reduce memory footprinting with something like, if you have multiple instances on the same hardware, you can reduce it with KSM, which is same kernel, same page merging. which induces a certain cost, but it certainly reduces the memory footprint. The cost is in terms of CPU, but it shouldn't be much. And then you can also have a certain scenario like where you can use ballooning. Suppose you have a 5.5 node, and you want to upgrade, and you don't want to bring down the node. So what you can do is you can have 2 nodes on the same. One of them with a lesser memory footprint. So you can bring down this node slowly and bring that up, which is during the upgrades, and you can use ballooning for that. For those of you who are not aware of it, memory ballooning can be used for dynamically resizing the memory of a node. Think of it as like a balloon. Anyways, and you can use load balancing among the nodes with that. And one more thing is, suppose you have multiple instances on the same node and you'd like to migrate them. You can use the block streaming feature of QEMU for that, for live migration. And the thing here is that after migration, since it's a lazy live migration, once this node goes down and that node comes up, the whatever effective synchronization which is required will happen, and the other node will be up. And the need for this may be during, I don't know, hardware maintenance and things like that. And since this is a cluster with the synchronous replication, so it's all the nodes should have the same state, so assuming they are working right. So there won't be any downtime as well. Okay. So one more thing I would just like to add here is that you can use QEMU guest agent. I'm not sure this FTWRL stands for flush tables with read lock, which is basically used with MySQL since it uses usually ODirect with InnoDB. So you use this with the guest agent. So you use it from the host to guest. This is a host to guest communications to state that there's a backup and it has to. So basically the host communicating directly with the application here. So that is the part here. And one more thing is shared storage. Suppose you have a storage shared between multiple hardware nodes, and you'd like again the same state cloning. You can either go for if you have something like a NAS between the nodes, you can go for something like copy on write or copy on read, which is again supported in QEMU based on whether it's LAN or WAN. Since with synchronous replication latency matters, you need to choose appropriately between them. Okay. How many? Yeah, so I'll just go through this faster. So in the storage, I would like to mention is if you have multiple instances again on the same node, if you want to pass a common route to the different instances, you can use virtualization to pass the entire route. With the newer FHS, it's even easier to pass. You can just pass the /user, and all the nodes should have the common root. So it should work better with package management and things like that. And okay, the network, finally the network. I think latency is the core element in any synchronous replication, and it can affect pre-commit stages and all that. So it's very important to keep latency low in such an environment, and network latency can be high in virtualized environments. So there is a need to keep them low as possible and as close to the bare metal as possible. So you can either use virtio.net, which is nothing but para-virtualized instances, or vhostnet, which requires which is not packaged by default, but it provides much higher performance, close to it's like 90% close to bare metal, I think, or even more. It's being developed now. So I think that's how much is left. Okay. So the roles I would like to mention is even if this is a homogeneous cluster, you may like to assign roles to them of reader or writer. This may be required if you have a non-homogeneous hardware, so that you don't want certain hardware to, or maybe they are sick hardware. You don't want them to take the load of a writer, so you can assign roles of a reader or a writer in such a situation. And backups, you can use dirty bitmap feature of again QEMU for that. Yeah, I think that's about it. If you have any questions, please.